Hello, my name is Alex. In this series of video tutorials, I will show you how to extend Magento functionality that involves visual aspects of customer-facing web pages. As you remember, in the first course, we created a module named Controller Test. The controller we wrote was simple, capable of only echoing the Hello World string as output. In this video, we'll create a more complex module. We'll delve into the rendering process, marked in red. On this slide, you can see that rendering is the penultimate step in the request flow we discussed in the first course. Suppose that our online store sells some goods with free shipping to all countries, and we decide to change the multi-step checkout module that comes with Magento to give customers a faster way to complete their purchase. This video tutorial will help you better understand how the V, which stands for View in the MVC concept, is implemented in Magento. You'll learn how to alter layout and template files to adjust the view or functionality of a page. Also, you'll learn what the layout update files and templates are in Magento, what the difference is between a design and a skin, and how to work with each. Magento's native checkout module uses a sequence of AJAX interactions with the server to show relevant data for each step. To calculate totals, the system needs to know the shipping cost, which means the system needs to know the shipping method, which means it needs to know the shipping address. We can find quite a few commercial solutions for a one-page checkout, where mutually dependent files are live updated by means of AJAX technology. In this course, however, we're going to focus on manipulating the visual aspects of a page. In completing this course, we'll pilot you through the rendering process. We'll learn each part of Magento's View implementation. Let's get started. Our first step is to create a module skeleton. To do this, we open our namespace folder called Practice in the local code pool and create a new folder. Let's call it One Step Checkout. Next, we create two more folders inside the One Step Checkout folder and name them Etsy and Controllers. After that, we create the module's config.xml file in the Etsy folder. Excellent! You'll recognize all of these steps from the previous course. Open the config.xml file and add these lines of the code. Do you remember what you should do next so that the system can find our new module? Right! You need an initial configuration file in the app/etsy/modules folder. Create the file, naming it based on the pattern namespace_modulename.xml. In our case, this will be practice_onestepcheckout.xml. Open the file and add these lines. Notice that we added a depends node. This means that the module will work only when the three listed modules are active. Now we've got a new empty module, which is very similar to the one we created in the previous course. There are two major differences in creating this module from the steps we followed in the first course. First, we added the dependencies above. And second, we'll define the controllers in a different manner. Let's do this in the next video. Open the config.xml file in the module's Etsy folder and add these lines of code in the config node. As you are probably already familiar with the purpose of much of this code, we'll expand on just a few lines. The front-end node targets the controller declaration to the standard router, namely the Mage Core Controller Variant Router standard class. We haven't chosen the front-end area and standard router by chance. The system uses a checkout route declared in the front-end area of the native checkout module, and we want to update it by adding one more value. So, instead of creating a new unique route identifier, as we did in the first course, we use an existing one, checkout. Notice the way you can append values in the router's nodes of the system configuration. The syntax to do this is simple. First, refer to the existing route. Next, use the Modules node in the args node to add a new controller to the route. In addition, you can set either before or after attributes to assign a priority. We create one-step checkout to be a unique identifier, and the system uses it here for only one purpose, to hold values. We can make our identifier anything we want. The before attribute directs the system to insert the new controller class prefix practice_one-step-checkout that you see as a value in that node before the Mage_checkout prefix. This means that the system will look for a corresponding controller with a method using a practice_one-step-checkout prefix first. And only when a match is not found will the system try the next prefix, Mage_checkout. In the previous class, in the request flow lesson, we studied the collect routes method of the Mage Core Controller Variant Router Standard class. We mentioned that the code on lines 44 through 64 would not run for our configuration because we didn't have a modules node for that route. However, now we have the modules node in our configuration file. Take a look at these lines again, 44 through 64. The system sorts modules according to the before and after attributes and appends them in a modules array. This modules array actually contains prefixes like Mage_checkout or practice_one-step-checkout, and so on, ordered according to their before and after attribute values. This is a very convenient way to add a new controller to an existing route. Use this approach when you have a new controller and you want to call its actions under an existing route. Thus, the system will use your custom controller for the actions it contains, but when the system doesn't find a match, the system will use the next controller in a queue. Now, since you've learned how to add a new controller class prefix to an existing route and how to add your custom controller there, let's create a controller. In this video, we're going to create a controller for our one-step checkout module. Why do we need one? Our goal is to replace Magento's multi-step checkout process with a single-step process. So, we need a single method instead of many methods. Each step in a checkout process interacts with a server, in essence with a controller. The browser sends client data to and receives a response from the controller to adjust the contents of the fields as the checkout process proceeds. Open a checkout page of a Magento installation in your browser. You will see that the URL of the page is like this: your domain name / then possibly index.php /checkout /onepage/. Where do you think a native checkout controller is located? According to the URL, the route name is checkout. In the checkout's config.xml file you just saw, the route checkout linked to a module prefix, Mage_checkout. So let's open the Mage Checkout Controllers folder. And because the next part of the URL is OnePage, we open the OnePageController.php file. Looking at the code in this file, you might agree that to write one single method to create a client's order immediately, not step by step, isn't a simple task. Instead of writing the method we need, we'll take another approach. Let's extend the native checkout controller, namely Mage Checkout OnePage Controller. Then create a single method, let's say Save Cart Action, and include only the calls of all the parent's controller methods which we need, one after another. Now, let's create the controller file. Open your one-step checkout/controllers folder and create a new file. Call it onepagecontroller.php. Add these lines. You should understand this code, in particular, how the system arrives at the SaveCart action method based on the material we learned in the previous course. If you make a request like this, the system will call the method SaveCart action because it concatenates the words SaveCart and action to compose a method name. But there is one line I should explain. Require wants Mage checkout controllers onepagecontroller.php. Why do we include this checkout controller file explicitly? Remember that the lowercase controllers folder is outside the sphere of Magento's autoloader mechanism. So, we include the onepagecontroller.php file manually. We need this file because our class extends Mage checkout onepagecontroller. But the system won't find Mage checkout onepagecontroller automatically. The only way to have one controller extend another is to hard-code a reference to the extended controller in the custom controller. Here's an important note. When your custom controller is extended from another controller, all parents' methods are callable for the custom one, right? This is the basis of OOP. So what? If somewhere in the system we write another custom controller that extends the same native controller, we may have trouble. Why? Suppose we wrote two controllers, and both extend the same Mage checkout onepagecontroller class, and both are added to the same route. The first controller is the one we just wrote. It has only one custom action. Another controller is slightly different. It rewrites some methods of the parent class where it adds some other logic. What can we expect? We want the system to use the first controller only when that controller's single action is called. In other cases, we expect the system to use the second custom controller. But if the system starts to check from the first controller, it will never try that next custom controller, because the system can find all the methods of the parent controller using just the first custom controller. As a result, the system will ignore the logic of the second custom controller. This behavior may cause you a lot of pain when troubleshooting. So here is some advice when you write a controller. First, extend another class only if you need the original class's functionality. And second, when working with a highly customized Magento installation, make sure to define your controller in a proper route with a proper before-after attribute. You can avoid the problem in the previous example by forcing the system to start matching from the second custom controller. We could write after Mage checkout for the first controller instead of before Mage checkout, since we've defined a new action that does not exist in any of these classes. Although the system will try to match both of these classes first, it will find a match only for this controller in case of that new action. We need to place the second or two-page controller before the native one so that the system can use it for the overridden methods. We've done almost all the work on the controller in this video. We created a skeleton of the one-step checkout controller. To finish this task, we need to find out which methods of the parent's controller we need in the SaveCart action method. Let's do this in the next video. Let's use the simplest, fastest, and most popular way to find the name of the methods we need to include in the SaveCart action method of our one-page controller. To create a custom order on a checkout page, Magento uses Ajax technology. the browser sends an AJAX request on each step of the checkout process. So we need some tool to trace these requests. I prefer using the Firebug plugin for Firefox. As you can see on the screenshot, the browser requests save billing, then requests save shipping, then save shipping method, and finally save payment actions. The last step that the system waits for the customer to do is to click on a Place Order button. When the customer clicks that button, the system calls the Save Order action, as you can see here. All these methods are located in the native OnePageController.php file, which we included and then extended in the one-step checkout controller. Again, you can see this in the URL requests. Each of them has OnePage as a controller name. Let's add all of the methods we found to our Save Cart action method sequentially. As an experienced developer, you may think that this approach is not very efficient from a performance point of view, because each of the methods we are calling might do a bit of unnecessary work. Learning how to write highly efficient controllers is outside the scope of this course, but you are welcome to try it on your own. Okay, now we are done with the controller and are ready for the next step, to alter the layout. Before defining our layout update file, I'd like to explain the role of the layout mechanism in Magento. In Magento controllers, we mostly use a layout mechanism to build a web page. Each Magento module can define its own layout update XML file in its config.xml file. To render each page, the system loads all of the layout update files of the current package and theme, and then merges them into one layout object. That is why we call it an update file, because it yields an updated layout, which is a compendium of all the layout update files. Let's add the code you see on the slide to our config.xml file. Place it in the front-end node as follows. To add a new layout update, we add a layout node within the targeted area, front-end in our case, and then add an updates node. After that, we add the identifier of the layout update, namely one-step checkout. The identifier must be unique, otherwise you'll overwrite the value defined in the configuration of another module. Finally, we add the file name of a layout update file, which is onestepcheckout.xml in our case. Now, when the system loads all of the layout update files for the front-end area, it will also try to load the new onestepcheckout.xml file that we just defined. To target your layout update to the administration area, place its definition in the admin HTML node instead of in front-end. Excellent! We've defined our layout update file. Let's look deeper at what layout is. The layout concept can seem opaque at first. Nevertheless, don't be deceived into believing that to work with it, you must first be armed with an extensive knowledge of programming logic. The layout is built with a small set of XML tags that are easy and fun to learn. One of the benefits of Magento's layout mechanism is that instead of including template after template, as a typical e-commerce application would do, in order to gather the whole HTML output, Magento gathers and arranges page content through blocks. Using this layout mechanism allows you to seamlessly add and remove modules without affecting other modules in the system. Using a metaphor, we could say that the layout mechanism has two faces. One face is the ability to describe the structure of a page. The other face is the ability to penetrate into behavior. You'll see how these two faces work in a bit. If you go over Magento controllers, you'll see that the majority of a controller's actions call the load layout and render layout methods. Moreover, they might even be the only methods in the controller's action. So, in order to build a view and send it in response to a page request, a controller uses a layout mechanism, calling the load layout and render layout methods. As you see, initializing, which corresponds to the load layout method, and then rendering a layout, which corresponds to the render layout method, comprise the next step of the request flow. Magento provides ultimate upgradability, flexibility, and reusability of design by using this layout mechanism. A layout defines blocks for the system to use when building a page, whereas a template is HTML code for a block. Layout is a configuration for the blocks and its templates described in XML. You can easily alter any core page using a custom layout update file. Since to maintain upgradability, you should avoid editing core layout update and template files, we use a custom layout update file to redefine needed blocks and templates. To understand how this becomes possible, we need to understand the language we use for the layout mechanism. Right after the layout node, we have a level for handles. Any element on this level is treated as a handle. What is a handle? A handle is an identifier that contains a set of blocks. Blocks can be nested. When the system processes a layout on a load layout call, the system renders not all handles, but only those that are relevant to the page. In many cases, the system will find a match for at least two handles named default and action-based, where action-based is based on a pattern, route name _ controller name _ action name. In the case of a checkout page, this second handle is checkout _ one page _ index. You see here two other handles, store-based and theme-based. Yes, the system actually adds four handles by default, regardless of whether they are in the layout or not. We'll explain these four handles in detail a bit later. Here, we aim to highlight that the system will only use the matched handles. All of the handles beyond the list will be ignored. And one handle we need now is checkout _ one page _ index. Now that we are clear on what a handle is, let's see what you can manipulate in the handle. Look at the slide. We have 6 directives that we can use when working with layout update files. First, the label node defines the label of the handle, which is shown as a descriptive reference in some areas of the admin panel. Just put the value inside the tag like it's shown here. Second, the reference node is used to link an already defined block in any layout XML. Use the reference directive to add any child block to an existing block, to modify attributes of an existing block, or to perform any action on an existing block. The syntax is as follows. The reference node must have a name attribute, which refers to the existing block's name. To put this simply, a reference's content will be merged into a target block defined by a name attribute. Third, the remove node is a directive to remove an existing block from the layout. To remove any particular block, you must specify its name attribute. In fact, the system sets an ignore flag for the block specified in the node, so that the system will skip rendering the block. The syntax is as follows. Fourth is the update directive. This directive loads a specified layout handle into the current layout handle. It provides a kind of inheritance of layout handles. The syntax is as follows. The update directive must have the handle attribute, which defines the handle of the block to be included. We can use this directive to easily paste another entire handle structure inside a given handle. The remaining 2 directives, block and action, are more complex, and you can use more than one attribute for them. The block node is used to define a new block. Let's look at all the available attributes for the block. You can specify as many as 8 attributes for every block in a layout update file. First, the type, or its alias, the class, is the only mandatory attribute. It sets an identifier of a PHP class name. This class contains the functionality of a block. The name attribute specifies a name of a block. If you specify it, then you'll be able to use the value of the attribute for the reference directives. If you don't specify the name of a block, the block is created anonymously. The meaning of a template attribute is obvious. It defines which PHTML file should be used to render a block. But notice that not all blocks use the templates. We'll come back to that later. The as attribute is used to assign an alias for a block. Then, you are able to use it in a template file as a parameter of the getChildHTML method. An output attribute is used to define a method name that the system will use to gather an output instead of a default toHTML method. This attribute is mandatory only for the root block in a layout block hierarchy, because child blocks are called via templates by the getChildHTML method. You can even redefine a parent block using the parent attribute. This directive overrides regular XML nesting where a parent is defined naturally. But I must admit its usage is very rare. As you would expect, the before and after attributes are used to position your block before or after the specified block. The value dash targets the block to the very top or bottom of the block's array. This attribute goes into effect only when a parent block is one of a number of specific types. For example, core/text list. In other cases, the order will be defined in a template for a parent's block. Phew! Now we have the last directive for layout. The action defines an action to be performed on the referenced or newly defined block. Here, you can see an example of the action calls in the checkout.xml file. All child elements of the action element are treated as parameters of the method specified with a method attribute. You can place this element inside reference or block elements. Look at this slide. As you see, we have 7 attributes available to manipulate an action. The method attribute defines the exact method name which should be called on a block instance defined in a block attribute, or else on a parent block instance. The ifConfig attribute allows checking a configuration flag value before the action processing. In case some values in the child nodes are JSON encoded, you can define the JSON attribute for an action and then list there all of that child's node names. The system will decode the values first and then will pass the values to the block method as parameters. On the slide, you can also see the next attributes, translate and module. The translate attribute of an action indicates which child nodes of an action must be passed through the translation procedure. Usually, this attribute refers to the label only, translate label. In the translate attribute, you can list nodes in the same manner as you do in the JSON attribute. If the module attribute is not specified, the system will use the core helper. Otherwise, the system will take a helper of a module that is specified in the module attribute. The last attribute, the helper, is used for child nodes of an action node. The helper attribute allows calling a user function to perform additional data conversion, formatting, or generating of the target value. You can see on the slide that a provided helper value must follow the pattern helper name/helper method. As you can see, what layout actually does is operate with blocks. it defines a hierarchy of blocks that are grouped by handles. You can define a block with the block directive, refer to a block with the reference directive, call an action of a block with the action directive, and delete the block with the remove directive. Now that you have a more extensive understanding of what a layout is and its language, let's create one. To create a layout update file, we need to know the proper place for it. Magento stores all layout XML files in the app/design/area name/package name/theme name/layout folder. This means that we need to open the app/design folder and then the front-end folder because we are creating a layout for the front-end area. The next level is the package name, and since we cannot foresee which package will be used on every customer's Magento installation, we choose the default package here. And finally, we need a theme name. Let's create our own theme for the module. Let's call it Practice, lowercase. So create the folder and name it Practice inside the default package. Then, we need to create a layout folder inside the Practice folder. Excellent! At last, we can create our layout update file. We name it the same way that we defined it in the config.xml, namely onestepcheckout.xml. Look at the slide. Add these lines of code. As you already know, first-level child elements of the layout node are called layout handles. Which handle name will we use in this case? Remember, we mentioned action-based handles with the pattern route name _ controller name _ action name. The getFullActionName method of the MageCore controller variant action class composes this handle name. Which handle will Magento use for the checkout page if the URL is domain name/checkout/onepage? This handle is checkout_onepage_index. Let's find this handle in the native checkout.xml layout update file. It contains the code you see on this slide. Add lines 300 through 338 to your onestepcheckout.xml file inside the layout node. Now we are ready to change a view of the checkout page. Change the label One Page Checkout to One Step Checkout. Add the line Remove Name Right after Remove Name Left. In reference name root, change template page 2 columns right .html to page 1 column.html. We can completely remove reference name right and its content because we don't need it anymore. Your handle should look like this. So what have we just done? We wrote a directive to remove the block named right. Then, we changed the name of the template with one column.html because we want to have the checkout page stretched across all the available width. We don't want left and right blocks on the page. And after that, we remove the content of the right block since we're not using it anymore. Let's move ahead. The next line is reference name content. Put the directive remove name checkout.onepage right after the reference. Change the next line, line 23, from type checkout/onepage to one step checkout/onestep. Then name checkout.onepage to one step checkout.onestep. And finally, change template checkout/onepage.phtml to template checkout/onestep.phtml. Remove block type checkout onepage login node and all of its content. Remove block type checkout onepage shipping method additional and its content. Remove block type checkout onepage review and its content. What do we have now? Our layout update file should look like this. Why did we remove the checkout.onepage block? because we wanted to replace it with a new one, namely onestepcheckout.onestep. To do this, first we delete the checkout one page using the remove directive, and then we create the new one, onestepcheckout.onestep, by editing the current block. We specified a new type, a new name, and a new template, and we kept some nested content. What would happen if we only renamed the block? Since we have at least two handles with the same name of Checkout One Page Index, one in the native checkout and another in our current checkout, the system will combine them and you will see aggregated content. And you'll still see old core block content. By the way, all this illustrates how we can change a handle's content and at the same time avoid editing core layout update files. To summarize, in our module, we decided not to show a login step when the customer is on the checkout page. That's why we removed the handle with the name Checkout One Page Login. Also, because we're going to limit the list of available shipping methods, we won't have any additional methods. That is why we removed the handle with the name Checkout One Page Shipping Method Additional. In the native checkout, when all data is sent, that is, when all steps are done, the server then shows a review page with a Create Order button. For the purposes of this course, we want to create an order without that validation page. That is why we also removed a block named Checkout One Page Review. Now we finished the layout update file, so let's go to the next step, creating a block. What is a block? A block is a PHP class that encapsulates any functionality needed to show the block on a page. If you need to fill some area on a page, namely some fields, tables, etc., with data from a database, you will typically do it by calling the model in a method of a block. Blocks interact with models. We won't discuss the concept of a model in this course, except to say that Magento uses models in blocks. Having discussed the layout concept, we now come to the block concept. Layout is the XML definition of the blocks that are used. Block is a PHP class. Magento creates instances of all the blocks listed in the handle that was matched for a given page. This happens on the load layout method call. Then Magento runs the toHTML method of each block, and that is when templates are used. The system will include the template file that we specified for the block in a layout update file to render the HTML view of a block. A template can use the PHP methods of its block in a simple way like on this line. You might notice that we actually work with a conceptual triangle: layout, block, and template. We'll come back to template a bit later. Now let's look at a block. In Magento, we can create blocks of different types. Look at this slide. All of these blocks extend Mage Core Block Abstract, either directly or through the others. This list shows only a few of the PHP classes that you can extend from when creating your block. They can speed up your development process. The core template block renders a template defined by its template attribute. The majority of blocks defined in the layout are a type or subtype of core template. When the system renders a block type of core text_list, all its child blocks are rendered automatically without the need to call the getChildHTML method. Some blocks like content, left, right, and others extend core text_list. The core messages block renders error, success, and notice messages. The page template_links block can be used to create a list of links. And page switch can be used to render a store switcher. You should be aware that some types of blocks require a template to be rendered, and some don't. When you use core template, you should specify a corresponding template file, and the file will define how the block looks. If you open any PHTML file in the template folder, you will see frequent getChildHTML method calls. As a parameter of each getChildHTML method, we specified an alias of the child block that we defined in the layout. Don't confuse an alias attribute with a name attribute. We need to use a value of the as attribute here. This is an alias of a block. You can see on the slide that the block header was defined with an alias header. Then, the 3columns.phTML template uses this block via the alias on line 42. Back to our module. Be careful to define all blocks in the layout update file before you call them in the template. For example, if we call a block methods via the getChildHTML method in a template, we need to define that block in a layout update file. If you don't, the load layout method won't instantiate the blocks and getChildHTML will return a blank output. Looking from the other point of view, when you reuse the same template in your block but don't need several of the nested blocks, you can simply remove them in your layout update file as we did. Because of this functionality, these blocks will simply disappear from a page without editing the template. Now on to the next step, creating our block. In our layout update file, we define the new block one-step checkout one-step. In the Magecheckout block one-page class, we need to change the getSteps method. Since we decided to remove the login block from the checkout page, we need to remove some logic from the method. In your module folder, One-Step Checkout, create a new folder named Block with the first letter capitalized. Then create a new file named OneStepPHP. We are going to extend this class from a native one, Magecheckout block one page. Then we want to change only one method, getSteps. If you take a look at the native getSteps method, you will see that we don't need the selected code anymore. So write your column getSteps method and check it with what you see on the slide. After we create a new block, we need to define it in our configuration file. Let's do that now. Open your module's etc/config.xml file and add the code selected on the slide. This code shows the system where it can find the file for our custom block. When the system renders a layout, it looks for a block with the type OneStepCheckout/OneStep. Remember, we defined the type in our layout update file. The system splits OneStepCheckout/OneStep into an array using the slash as a separator. The first element of an array, the word OneStepCheckout, works as an alias for the Practice One-Step Checkout block class identifier. As you see on the slide, this value, Practice One-Step Checkout block, is assigned to the variable group because Practice One-Step Checkout block serves as a prefix for the group of blocks. Then, the system composes the class name by concatenating Practice One-Step Checkout block in the second part of an array, the value of which is one step. This makes the second value, which is followed by a slash, a sort of suffix. The system uses the underscore as a sort of glue, and then applies the custom useWords function to the result. You end up with a class name where the first letter of each word is capitalized. Then, the class is loaded by using the autoloader mechanism that we discussed in the previous course. This is how we usually define block identifiers for the block classes in Magento. Then we can refer to every block in a block folder using that class identifier, OneStepCheckout. It serves like an alias on a prefix to all module blocks. Another approach you should be familiar with is the rewrite mechanism. We could leave the type of the block as is. All we needed to change was the name and template attributes. Then we could change the code in our config.xml file. Look at the slide. Here, we rewrote the one-page class name with another class name. So the reference, checkout/onepage, now points to the class Practice One-Step Checkout Block One-Step. This definition differs from the first, since we are defining not a prefix for a group of custom blocks, but we rewrite only one specific class of a block. We wanted to replace the native block in the template file name, and we got it. In this second approach, we altered only the template and name attributes. Then, we wrote the rewrite entry in the config XML file for the existing type of block. If we ask the system to create a block of the type checkout/onepage before this rewrite, what class name would the system compose? According to the logic we explained a bit ago, it would be Mage Checkout Block OnePage, since we have this definition checkout block in Checkout Config XML. But we've rewritten the checkout node in blocks in our custom one-step checkout module's config.xml file. And now a new value will be taken for class name due to the logic in Mage Core Model Config class on line 1234. When we refer in our layout update file to this type, the system will use the new substituted value. Instead of the Mage Checkout Block OnePage class instance, it now creates the Practice One-Step Checkout Block OneStep class instance. You can use this rewrite technique not only with blocks, but with models and helpers. Why do we need to edit the name of the block? We did this to prevent the remove directive from deleting our custom block because of the name's sameness with the native block. Excellent! Now we are almost ready to test our module, but first it's time to work out a template issue. Our next step is to create a folder for all of the template files we'll use. Open the folder App Design Front-End Default Practice and create a folder named Template. Look at the slide. I list all of the templates we need to edit to make them work under our one-step checkout module. Locate them all in our handle based on this screenshot and change the path from one-page folder to one-step folder. We can copy these files from the App Design Front-End Base Default Template Checkout and Checkout One-Page folders into the App Design Front-End Default Practice Template Checkout and Checkout One-Step folders. We need to edit these template files to get the results we expect. Let's start from the one-step PHTML file. First off, edit line 28. Enter the string one-step checkout to replace the string checkout. Then edit line 36. Use this for the class name, class section allow active. We don't want to change the style for blocks depending on the current step. Now scroll to line 42 and remove Style Display None. In our case, we want to show all of the blocks at once. This is all we need to do to the file for now. Notice line 43. Echo this getChildHTML step ID. This is the name of a function that we mentioned earlier. You see here we are inside a cycle for each this getSteps, and the method getSteps is defined in the custom block that we just created. The function returns names for blocks, and the names must be the same names that we have in our layout update file inside the handle checkout one-page index as a value for the as attribute. Look at the slide. Check if everything is correct. Let's move ahead. Open the file billing.phtml from the one-step folder. Delete lines 173 through 179, since we won't implement this functionality in our one-step checkout. Then delete line 185. After that, on the next line, 186, add style visibility hidden into a button tag. Your code should look like this. The next file to edit is shipping.phtml. Delete line 135 and add a string style visibility hidden in a button tag on line 137. Do the same in the shipping method PHTML file. Add the string style visibility hidden in a button tag on line 41. Now we have the last file in the folder, payment PHTML. To do all the work that JavaScript does on a client's browser, we need a new JavaScript class. Suppose we already have this class, and now we're going to add this class in the template. Add the line that you see on the slide right after line 29 in your payment.phtml file. Lines 30 through 33 are new, so add them to your payment.phtml file. Then replace onClick Payment Save with onClick One-Step Save on line 49. You can replace the word Continue with the words Create Order on that line as well. Check your result with what you see on the screen. Good. Now we need to include a JavaScript file for that class, OneStep, that we are using in payment.phtml. Go back to OneStep.phtml and add a line after line 29. This new line is line 31 on the slide. Excellent. We are almost done with the template. We'll go back to one last template, shipping method available PHTML, a bit later. Now let's create the above-mentioned OneStepCheckout.js. Now we come to the last concept of the course, the skin. The skin is where Magento stores all CSS, image, and user interface-specific JavaScript files. In the root folder of Magento, we have the skin folder. This is where all skin files are located. Open Skin Front-End Default and create a folder named Practice. Then create the folder JS, lowercase, inside the Practice folder. Finally, create the file OneStepCheckout.js in the JS folder. Now we are going to create a class that will implement the functionality of the native checkout with a small modification. In your file, add the code that you see on the slide. I'm joking. Of course, I don't expect you to type the code from your monitor. You can open a native JavaScript file, namely skin front-end base default js op.checkout.js, and copy lines 809 through 881. Rename the class to OneStep on lines 1 and 2. Rename Agreement Form to Parent ID on line 3. And change line 6 to this, Parent ID equals Parent ID, as you see here. Open the opcheckout.js file again and copy the content of the save function of the payment class. This is on lines 748 through 764. Use it to replace the save method of our OneStep class in OneStepCheckout.js. Now we'll make some modifications inside the function. Remove line 12 and the first part of the condition on line 14. Then replace this form with this parent ID on lines 13 and 23. Check your code against this screenshot. The variable parent ID serves the purpose of finding a correct container where all fields of a form are located. We'll send it as a parameter for the method formSerialize. What does it contain as a value? Look in the file payment.phtml. On line 30, you see New OneStep. And then on line 33, Checkout Steps as the third parameter, which answer our question. You can find to what this identifier corresponds in the file OneStep.phtml on line 36. Now you see that the formSerialize function serializes every field value within the alt tag with the Checkout Steps ID. So back to line 22. Now you understand that all of the form values will be gathered and sent to a server as the AJAX request parameters. We are almost ready to test the result. If you try to test it now, you'll see a screen like this. This happens because we rewrote one PHP block and changed its functionality. None of the changes with the layout, template, and skin files are applied yet. To point the system to use them, we need to turn on our custom theme named Practice. Let's do it now. The simplest way to change a theme is to define a new theme for each entity that we need in our config.xml file. Just put the code you see on the slide on lines 44 through 54 into your module config.xml file. If you try it now, you should see all of the changes we've applied. But you might not see the changes. First off, we assume that your store is named default, as you can see here. Secondly, you might not see the changes if you once changed your theme in your administration panel. After your changes under administration panel were stored in the database, the system will ignore subsequent theme definitions from config.xml files. In this case, we need to open the page System, Configuration in the top menu of the admin panel, and then open the Design tab. Specify our theme, Practice, in the Templates, Skin, and Layout fields as you see on the slide. When you need to change the theme for one or two fields, this is an apt approach. But here, we are changing almost all of the fields, so we can use just one field, Default, and point the new theme there, Practice. Check your checkout page now. It should look as we expect. Now, let's create an order. If you start to check out after placing one or more products in your cart, you will see that the Shipping Method tab on your checkout page is empty. When you try to create an order, you might see an alert like this. Please specify a shipping method. How can we do this when we have no options available on the tab? This is so because the logic of the native checkout determines a list of available shipping methods after saving the shipping address. Since we decided not to implement live updating for one-step checkout, we have broken the functionality for now. But we can hack the problem by way of limiting the shipping method to one hard-coded free shipping method. Open your last unchanged template file, shippingmethod/available.phtml, and replace all of its contents with what you see on the slide. Then, make sure that this shipping method is active in your admin panel. These last steps on the shipping method are a very specific and localized hack that we have to take only because of the scope of our course. So far, your checkout should work as expected. Let's verify. Excellent. Now, after having successfully created an order, we can talk about another important concept: design fallback. Before we cover details of design fallback, let me say a couple of words about themes in Magento and what they control. As I show on this slide, at least 3 main points are entrusted to the theme. These are the visual aspects, functional aspects, and the separation of the presentation layer and the functionality that stands behind it. We are already familiar with the concept of theme in Magento. We created our custom theme, Practice, and put all of our templates and layout update files there. Then, we did the same in the Skin folder. There, we created a folder named Practice for our custom JavaScript. You can now see that any theme consists of layout update files and templates in one place, namely the Design folder, and CSS, image, and JavaScript files in another place, namely the Skin folder. Despite the fact that these files are in different places, they all represent one theme. What is located in the Skin folder manages mostly how a page looks, and what is located in the App Design folder manages the whole content and functionality. Because all of these files represent one theme, you can easily switch between them, or create a design change for your store that goes into effect on a particular date. Themes are separated or grouped in packages. Packages, in turn, are grouped by areas. If you open app/design, you will see admin HTML, front-end, and install folders. These folders represent areas, and a matched controller sets the area name we are working with. Then the system looks for the layout update files, taking into account the current area name. That is, the system will notice our custom layout update file, onestepcheckout.xml, only when the request is for the front-end area. Let's move on. Open the front-end folder. There you see base and default folders. These are design packages. You can set which package Magento must work with in the admin panel in System Configuration Design Package tab. This will change the package used for the front-end area. For the admin panel, Magento uses a value from a configuration file. You can see it in the core/mage/admin.html/etsy/config.xml file on line 203. A design package contains a new design for your store. It is composed of the default theme located in the folder named Default and possibly several custom themes. But these custom themes are usually based on that default and contain only changed files. By basing your custom theme on the default, you reduce your work of creating a new theme and reduce the size of the theme folder, because you don't need to duplicate all files. This approach becomes possible by means of the design fallback functionality. What is that? When a requested file, a template, or a layout update file is not found in the specified theme, in our case it would be the practice folder, the system looks in the default folder of a current package. In other words, the system checks if the missing item is in the default theme. If it is not there, the system will use the base package and its default theme. This is how the fallback mechanism works. You can create your theme inside your design package simply by extending the default theme without any unnecessary file duplication. The rest of the necessary files will be taken from the default theme or from another default theme of the base design package. We see that the system will try as many as 3 times to locate a requested file of a theme, as illustrated on the slide. Take a look at this slide. You can see that the folder nesting in the skin and design folders is almost identical. Both have similar nesting in this area, then package, then theme. When you set a new package for your store, the system applies both parts of its theme to skin and design as illustrated on the slide. Okay, now you have a solid understanding of how visual aspects are implemented in Magento. In the first course, we came to a controller's action and omitted the rendering part. In this course, we've created a simple working module which deals mostly with the second part of request flow processing. Now let's take up the journey as the PHP interpreter does. If you open onepagecontroller.php in your one-step checkout module, you will see the method SaveCartAction, and inside it, 5 other methods of the native checkout class. Let's follow any of these 5 methods, for example, SaveBillingAction. In this method, you don't see any loadLayout or renderLayout methods, because each method we are calling within the method SaveCartAction works through the AJAX and does not require templates in this case. Scroll the script to line 151 and find the method indexAction. Here, we see the load layout and render layout methods. What do they do? If you open Magento controller variant action.php, you will find the method load layout on line 250. On line 254, you will see that the system adds a handle named default if no handle was specified in the method parameters. This is so in our case, so we expect that the first added handle is default. On line 254, the system adds some more handles. Let's open the method addActionLayoutHandles. This method adds 3 more handles to the layout update object. On line 281, the method adds the store_default handle. If your store code was changed, the name of this handle may differ. On line 285, the method adds the theme_frontend_default_practice handle. And finally, on line 290, the method adds the checkout_onepage_index handle. As a result, we have 4 handles. In my case, they look like this. The handle default was added in load layout, and the next 3 are added here in the addActionLayoutHandles method. What's next? Line 260 calls the method loadLayoutUpdates. This method will load layout update files from the file system and merge them with the layout update entries from the database. This functionality is located in the Magento Model Layout Update class. The action class runs the load method of the layout update class on line 307. Let's move there. This is the body of the load method. Notice an important detail on line 223. The system will merge only those handles which were earlier added to the handles array. This for each operation works, in essence, as a filter, so that only matched or required handles for a page will be merged. All other handles will be ignored. To get the update directive working, a recursion was implemented. You can see it on line 379. In general, the merging process will walk through 5 methods of the layout update class. First, it starts with the fetch package layout updates method, which runs fetch file layout updates, and that method, in turn, runs the get file layout updates XML method. On this step, all update XML files are processed, and in our case, 4 handles were selected and merged. After that, the fetch recursive updates method is called, and if selected handles contain an update instruction, additional handles will be merged into this layout object recursively. After that, the fetchDB layout updates method is called, which means that layout update entries from the database can overwrite the resulting layout objects. This explains the priority of the layout update of database over XML files. In addition to the filtering concept based on selecting a proper set of handles, I'd like to show you the design fallback implementation. If you scroll to line 268, you will see that to load files of the layout update XML, the system needs to know the proper path to their folder. The system needs an area name, line 269, then a package name, line 270, and finally a current theme, line 271. The functionality to detect and return proper values is located in a class Magento Model Design Package. It keeps a value for an area. A matched controller sets this value on its pre-dispatch call. Remember this. You can see on the slide how this is implemented in Magento Controller Front Action class, which is a parent class for all front controllers. The same applies for MageAdmin HTML Controller Action, which is a parent class for all admin panel controllers. Let's go back to the Package Design class. The method getArea returns the front-end area name by default, or a value that a corresponding controller has applied. The other two methods return a package name and a theme name respectively. They get the names via the Mage getStoreConfig static method. You remember that values stored in a database have a higher priority than those written in XML configuration files. We explained this in the design fallback video. So, when the method getFileLayoutUpdatesXML executes, it calls the method getLayoutFileName of package_design class, as you see on line 421. This package_design class performs all of the fallback magic that we discussed in the design fallback video. The heart of this is located in the protected function _fallback. On line 422, you can see that the system will try the current value for theme, and then on the next line, it takes a value of the config object design/theme/default. After that, it will try a value of a default_theme constant, which stands for default. Finally, if the file is still not found, the system sets new values for a package and a theme on lines 402 and 403, and tries the theme default of the package base. Okay, let's go back to the load_layout method of the variant action class. Line 265 calls the method generateLayoutXML, which calls the generateXML method of the layout class. That method processes all of the XML nodes and performs the remove directive. That is, it applies additional filtering on a merged layout object by setting the ignore flag for all removed blocks of selected handles. They won't be passed to the output. In addition, the method also removes blocks forbidden by ACL settings. On line 270, you can see the last method, generateLayoutBlocks. The method traverses the prepared layout XML object and creates instances of blocks for each block directive, and calls the block's methods defined by the action directive. Remember this: the method loadLayout finishes on instantiating all required blocks and running all defined actions which were selected in the actual layout. But again, the method doesn't instantiate every single block, nor run every action of all the layout update XML files. It refers to only those for which handles were selected. 4 handles in our case. Good. The next part of our story is the renderLayout method. After the system processes the renderTitle method, which adds titles to the head block, and then does some other actions, it finally comes to the main point. Line 391, the place of the main magic. Here, the system gathers all output and then sends it onto the response object on line 393. You are about to see the end of the entire request flow cycle. If you open the Mage Core Model Layout class and scroll to line 525, you'll find the function getOutput. Despite its simple appearance, this function is definitely not easy to understand. Usually, we have only one output block defined in the page.xml layout update file. You can see it on line 35. This block named root and its output property has a value 2HTML. So how do you think the for each you see here works? The system takes an instance of the root block and runs its 2HTML method. I'd say it's simple, but it's really not trivial. You will find the implementation of the 2HTML method in the Mage Core Block Abstract class. This is the public final method, and you cannot override it. But there is a way to penetrate into the method by overriding the protected 2HTML method, and many classes do that. For example, Mage Core Block Template does it. By the way, that root block we see here and saw before, page/HTML, which stands for the Mage Page Block HTML class, extends Mage Core Block Template. Look at the slide. The 2HTML method moves us to the renderView method and then to the fetchView method. The most interesting line for us is line 241, where the system includes a template file, namely the .phtml file, which was assigned for the block. This is how template-based blocks work. You can study how the logic of other blocks differ. For example, the logic of Mage Core Block Text or Mage Core Block Text List on your own. Remember, this is where the system delegates work to a .html or template file. If you open any .phtml file from the base package and the default theme, you will see plenty of getChildHTML methods, which return output of the blocks, named as parameters. How does this work? When your .html files are included, every getChildHTML calls the getChildHTML of the Mage Core Block abstract class. Take a look at line 582. Does this look familiar? The toHTML method of each block listed in your given .html file will be called over here. In fact, it looks like blocks produce nested blocks and so on. Take a look into one mirror using another mirror and you will understand the recursion I mean here. Let's go back to the render layout method. The system gathers into the output variable all of the output produced by all of the nested blocks on line 391 and sends it to the client on line 393. Excellent! Now we've come to the end of this long story that started from a client request, passed through initializing application, loading configuration files, initializing front controller, matching corresponding router, dispatching action controller, and finally loading and rendering the layout. Then, front controller sends all the produced output as a response to a client. Congratulations! We created a module, and in the process, learned how to adjust visual aspects of customer-facing web pages. Now you know what words like layout, block, template, area, package, theme, and many others mean in the context of Magento. We started with creating a module skeleton, very much like we did in the previous course, but we learned how to insert a new controller in the controller's queue for an existing route. Then, we learned how to extend one controller from another, taking into account Magento's autoloader mechanism. Next, we learned how to trace AJAX requests and added the requested methods to our custom method. We defined and created our own layout update file and learned what the layout language is. In our layout update file, we redefined the handle that corresponds to our request. Then, we learned how to define a new block prefix for your module and, in addition, how to rewrite one particular block class using Magento's rewrite mechanism. We altered core templates. We placed copies of only the necessary files in our custom theme and made the required modifications. Then, we moved on to the skin. The module needed a custom JavaScript file, so we created our custom theme inside the skin folder. Finally, we learned how to manipulate themes. Now you know how to adjust the visual aspects of a Magento page. Thank you for watching. Be sure and visit the Magento support site for more learning resources.